What's up? I'm Vin, and today I'm going through the January 2023 Geometry Regents, and I'm doing parts 2, 3, and 4. I'll leave a link to a copy of this test in the description below. And I'm starting off here with part 2, where each question is worth 2 credits. Question 25, we're going to construct the angle bisector of angle ABC. That's this angle over here in this corner. Now, it's very important that you make sure you bisect the correct angle, and one way to tell is the middle letter tells you the vertex of the angle. So here, what we have is we're going to extend the compass, and we're going to swing an arc so that it hits the angle at one location, and then we swing an arc again without changing the length of the compass so that it hits the angle in a second location like this. And now what we could do is we move the compass over to the intersection here, and we're going to swing an arc, and you could imagine the angle bisector is going to come right down the middle like this. So when I swing this arc, I want to make sure that it's going to pass through eventually where that angle bisector is going to go. So I swing an arc like this, and that should be fine. And I'm going to move the compass over here, and I'm going to swing another arc so that it intersects the one I just made previously. So now we're ready to construct our angle bisector. So I would place a ruler over here at vertex B, and I'm going to aim it for this point over here that we just made, this intersection point. And there we have it. This ray that we just went ahead and constructed here is the angle bisector of angle ABC. For question 26, we have triangles ABC and DEF are graphed below, and we need to describe a sequence of rigid motions that will map triangle ABC onto triangle DEF. So for a question like this, the first thing I notice right away is that this first triangle is going to be rotated 90 degrees clockwise, and then there's going to be some sort of translation. But me personally, I cannot memorize the formulas for the rotation. So what I do is I take the paper and I physically rotate it 90 degrees clockwise, and I pretend that this is my new XY axis. And I think here, okay, what would be the new coordinates of triangle ABC if I rotate it 90 degrees clockwise about the origin? And notice B would be over here at 1, 1. So I'll call this for a moment B prime. And then A would be over at, we would be at 1, 2, 3, 4, 5, up 1. So we're going over 1, 2, 3, 4, 5, and then up 1 like this. So this would be the coordinates here of A prime. And then next C would go to 1 and then up 1, 2, 3. So I'm going over 1, up 1, 2, 3 like this. So these would be the coordinates of C prime, and then this will make it easier to identify our translation. So now that we have this triangle mapped out, now what we could do is we're just going to go ahead and see how many boxes do we have to count over and down to get, let's say, point B prime here. So we're focusing on B prime. How do we get B prime to go to point E? Well, we would have to go to the right 1 unit, and we'd have to go down 1, 2, 3, 4 units like this. So far it's looking like 90-degree rotation clockwise about the origin, and then going over 1, down 4. But to double check, just to be safe, let's say I take point C prime here. I go over 1 and down 1, 2, 3, 4, and that'll map us to F. And then if I take A prime, I go over 1 and then down 1, 2, 3, 4. Notice that that translation maps all of these points here to triangle DEF. Now, some key details in our solution here. We have to, for one, emphasize the direction we're rotating, that we're rotating clockwise, and you have to mention your center of rotation. If you leave the center of rotation out of your explanation, you're only going to get 1 out of 2. So make sure you include all that. So question 27, we have a diagram of a roof, and the frame goes 4 feet above the house, and there's a width here of 24 feet. And we need to determine and state to the nearest degree the angle of elevation of the roof frame. So that's this angle over here, which I'll just put a theta. So to find this, notice that this is symmetric. That's a big detail here. So if I go ahead and drop down this altitude here, they told us the roof goes up 4 feet above. So this I could label as 4 feet like this, but since this is symmetric, I could go ahead and chop out this right triangle here. And the base of this right triangle is going to be 12 feet because once again, this roof is symmetric. So what we could do is we could extract that triangle over here. So we have a right triangle. We'll call this angle theta, and then this side is going to be 4, this side is going to be 12. So what we know is that tangent of theta is equal to 4 over 12. And once again, remembering this phrase, SOHCAHTOA. And if you think about the angle we were given here, this is the side adjacent to the angle, and this is the side opposite the angle, and the hypotenuse we don't have. We could find it, but we don't need to for this question. So tangent makes the most sense since we know the opposite and adjacent side. But if we want the angle itself, the angle theta, we do the opposite of tangent, which is tangent inverse, and we plug in the ratio 4 over 12, and this will give us our answer. So we go to the calculator, and we're going to press mode first. Make sure you're in degrees because the question said to round to the nearest degree. And now we go to get tangent inverse. We press second tangent, and now we type in the ratio 4 over 12. And after we press enter, rounding to the nearest degree, this is going to be 18 degrees. So 18 degrees is our final answer. So question 28, we have line segment AB and the endpoints are here. And then we're told to determine and state the coordinates of P, and that's the point that divides the line segment into a ratio of 3 to 2. So the first thing I imagine with questions like this, or you could even draw this on paper, is I imagine a line segment like this, and here's, let's say, A and here's B, and this is not necessarily the direction this is going, but we have points along the way. This is going to break into 5 equal parts, and I know that because this is a 3 to 2 ratio, which is 5 total parts. So I would have here, let's say 1, 2, 3, and then here's 4 and 5. So point P would be somewhere over here, because notice I have 1, 2, 3 pieces of equal length, and then I have 2 pieces of equal length right after point P. So that's what they mean by the location of point P. But the way you find this stuff is, or at least the way I like to do it, is first I like to calculate the change in X. So think of this as X1, Y1, and this is the point X2, Y2. And what we have here is if we find delta X, the change in X is going to be 8 minus negative 2, which is positive 10. But remember, I'm breaking this into 5 equal parts. So if I take delta X and I divide it by 5, my change in X is going to be 2. But this is what made this question especially difficult. If we calculate our change in Y, we're going to have negative 1 minus 5. And that's going to equal negative 6. So if I divide this by 5, so I'm taking delta Y and dividing by 5, this one here, and I'll just make this a little bit neater, so delta Y divided by 5 would be negative 6 over 5, which would be negative 1.2. So what was not polite about this question is if you try to use the grid, you're going to have wacky decimals going on here. So that's not necessarily going to be so helpful unless you just have amazing eyesight or you bring a magnifying glass to the test. So here, what I'm going to do is I'm going to make my XY just so you could really see the concept. Otherwise, like me personally, I just do 3 times this value and add it to negative 2, and I do 3 times this value and add it to positive 5. But this will be more conceptual this way. So here, I'm starting at negative 2, 5, and now my x's, I'm going to change by 2 each time. So I go plus 2 gives me 0, plus another 2, plus another 2, another 2, and then here like this. And notice it takes me 1, 2, 3, 4, 5 jumps. That's that 5 equal parts we were talking about here. And then the y column, I'm going to subtract 1.2 each time. So I do 5 minus 1.2, and that's going to give me 3.8. If I subtract another 1.2, that gives me 2.6. If I do it again, that's going to give me 1.4. I do it again, that's going to give me 0.2. And I do it one more time, and notice this throws me exactly to 8, negative 1, which is where I need to be. But remember, this is like the first point. So this is first, second, third, fourth along the way. So we're going to the 4th point along the way. So we have first, second, third, fourth. This is the solution to our question. Determine and state the coordinates of P would be the point 4, comma 1.4. But now I'm going to do my best to graph all of these. So you see here, if we plot all of these points here, that point P over at 1, 2, 3, 4, up 1.4, that you could attempt to plot A and B and connect them and then divide this into 5 equal parts. But notice that these points over here don't fall exactly on the corners here where all these axes intersect. It falls somewhere in between. So that's what I mean. Doing this visually is not going to be very polite. That's why I prefer to calculate delta X, delta Y, and then divide those by the number of parts in your line segment, and then that'll tell you how to essentially rise and run to get from one point to the next. So our solution is here. Point P is at 4, comma 1.4. Question 29, we have 2 triangles, and Brett claims that the 2 triangles are congruent and similar, and we have to answer, is Brett correct? And we have to explain why. So the first thing I would do here is draw both of them out. So we have triangle ABC, and I'm going to label this angle over here A, since A, the measure of angle A is 90 degrees. And I'm going to put B up here since AB is 5 units long and AC is 12 units long. That way this is somewhat to scale. And if you know your Pythagorean triples, BC is going to be 13 units long. But we could verify this with Pythagorean theorem by saying 5 squared plus 12 squared is equal to 13 squared. And this would give you 169 equals 169, which checks out. So these are the 3 sides of our right triangle. And then in triangle DEF, so I'll draw that next, we have triangle DEF. What we have here is the measure of angle D is 90 degrees. And then we're told here that DF is 12. So what I would notice also is that ABC, see how we went from here to here to here? So when we make DEF, we have to follow that same letter pattern here, that we're starting at the right angle, and then we're going up, and then we're going kind of in the southeast direction like this. So that's how I know this is going to be labeled correctly. And then what we have is DF is equal to 12, and then EF is equal to 13. So then right away, by default, this is another 5, 12, 13 triangle, another Pythagorean triple here. So we have all three sides of both triangles. So now we could just look at this and answer, is Brett correct? Right away, I'm going to say yes, Brett is correct. Now, how do we know he's correct? Well, these two triangles are congruent because they share three pairs of congruent sides. So by the side postulate. And then if we want to answer, are the two triangles similar? Well, we could just say right away that the triangles are also similar because all congruent triangles are also similar. Now, once again, for something like this, if we want to prove similarity, we could have used SSS similarity, showing that the three pairs of corresponding sides are all in proportion. So 5 over 5 equals 12 over 12 equals 13 over 13. We could also use the SAS similarity, but here, this is probably the most simple way to answer this question. So question 30, we have the volume of a triangular prism is 70 cubic inches, and we have the base of the prism is a right triangle with one leg whose measure is 5 inches. So the first thing I would do here is just draw this out. So I'm going to draw a right triangle, and I'm going to turn this into a 3D shape here. So this is going to be a triangular prism, and I'm not the greatest artist in the world, but it's going to look something like this. So almost like a block of cheese. And what we have is the height of the prism is 4 inches. So we have this is 4 inches. We have the leg here is 5 inches. And I'm not necessarily drawing this to scale. And we're told the volume is 70 cubic inches. So now what we need to do is we need to determine and state the length in inches of the other leg of the triangle. So what you need to know when you have a prism like this, the volume of a prism is equal to capital B times H, where this is the area of the base. Well, one thing to point out here is that our base is a right triangle. So when we want to find the volume here, we could say the volume of this thing is equal to 1/2 base times, well, you know what, I'm going to rename this because notice that it uses H already. So let's just call this kind of like length and width. So I'm going to say 1/2 instead of base times height, since H is already taken. I'm going to say 1/2 length times width, and then we're multiplying by height. So here, let's say that this 5 inches here is equal to, I'm going to just call this the length. Then the missing piece I'm going to call W, and then the height here would be 4 inches. So now we just have to make the substitution. We have the volume is equal to 70 cubic inches. And just know on the Regents, units are not something you're going to be responsible for. So you could go ahead and plug this in without the actual units, but by the time you get to physics, you have to write units all throughout your free response stuff. So, don't get into this habit for all your subjects. So we have 1/2 times length is 5 inches. So we're doing 1/2 times 5 times whatever W is times H is equal to 4. So now we just simplify a little bit. This is 70 equals, and if I do 5 times 4, that's 20, and 20 times 1/2 is going to give us 10. So we have 10 times W. And now dividing both sides by 10, this tells us that W is equal to 7. Question 31, we have triangle ABC, and these are the coordinates, and it's graphed below, and we need to determine and state the area of this triangle. So there's a few different ways we could go forward with this, but probably the easiest way to do this is to encase this in a rectangle. So what I'm going to do is I'm going to drop down this vertical line like this, and then I'm going to draw a horizontal line all the way across in such a way that when I drop down the next vertical line, it's going to go directly at point B here. And now I'm going to draw a horizontal line across. So notice that we have this big rectangle here in purple. And what I want to do instead, to find the area of triangle ABC, I'm going to find the area of this entire rectangle. And then I'm going to subtract the area of these 3 right triangles that were just made here. So these 3 right triangles over here. So one thing we could do is count the boxes. So we're going up 1, 2, 3, 4, 5, 6. So this triangle is going up 6 and over 1, 2, 3, 4, 5, 6. So this one is a 6 by 6, and remember the area of a triangle is equal to 1/2 base times height. And if I do 1/2 6 times 6, that's going to give me half of 36, which is 18. And now this triangle is going across 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 like this. And then we're going up 1, 2, 3. Now, let's just say that you're bad at counting or you lose place a lot. Just know this is the point -8, -1. And over here at B, this is the point 4, 2. So if you think about it, notice here that to get from -8 to +4, we have to go forward 12 units. So that's another way of seeing that this horizontal distance is 12, just in case you don't feel like counting boxes. So now, from this step, what I'm going to do is count this last triangle. It's going up 1, 2, 3. And then it's going across 1, 2, 3, 4, 5, 6. So then if we find the area of these other two triangles here, using this formula again, 1/2 base times height, or 1/2 of 6 times 3, would give me half of 18, which is 9. And then I'm doing half of 12 times 3, and half of 36 is 18 again. So now what I would do from here is to determine and state the area of triangle ABC. I would say here that the area of triangle ABC is equal to the area of the big rectangle. Notice that this is a 12 by 6. It goes across 12 and up 6. So this is 12 times 6 minus the sum of the areas of these three other triangles. So I would have the sum of 18 plus 18 plus 9. So now this is going to work out to 72 minus, and if we do 18 plus 18, that's 36, and 36 plus 9 is 45. And now this we could just punch in a calculator, but if we want to use some long subtraction here, I'm just going to go ahead and do that. So I'm going to borrow over here, and then 12 minus 5 is 7, and then 6 minus 4 is 2. So our answer here, the area of the triangle, is going to be 27 square units. Starting at question 32, we're in part 3, and the questions are now worth 4 credits. So for question 32, we have Sally and Mary getting ice cream. And Sally's ice cream is in the shape of a cylinder. Mary's ice cream is in the shape of a cone. And we could assume that the ice cream fills the shapes completely. And the first thing we want to answer is who was served more ice cream, Sally or Mary? And we have to justify our answer, which just means that we have to show math and choose something based on the math that we show. So the first thing that jumps out at me is that Sally's ice cream is in the shape of a cylinder. So the volume of a cylinder is pi r squared times h. Whereas Mary's ice cream is in the shape of a cone, and the volume of a cone is 1/3 pi r squared h. So that's going to determine how we find the volume. Now, one thing to be careful of here with both ice creams is that the diameter was given. So if we have a diameter of 4 centimeters, that means our radius is going to be half of that. So in Sally's case, the radius of her ice cream is going to be 2 centimeters like this. Whereas with Mary, her diameter of her cone is 7 centimeters across the top. So her radius, if we divide 7 centimeters by 2, is going to be 3.5 centimeters. So now that we have everything mapped out here, we could go ahead and find the volume. So I'm going to label this first. For Sally, we have volume equals pi times the radius squared. So we have 2 centimeters squared. And then we're multiplying by the height, which is going to be 8 centimeters. So this we just have to type into the calculator. So we've got pi, which is second in this up arrow here. And then we're doing 2 centimeters squared, but we're not going to write the units in the calculator. And we're going to multiply that by 8. So this is going to work out to the nearest hundredth, 100.53. So this volume is 100.53. And the units here are going to be cubic centimeters. So we have cubic centimeters like this. So now next up is Mary. So when we find the volume for Mary's ice cream, we're going to do volume equals 1/3 pi times the radius. Remember, we're taking half of 7, which is 3.5. So we have 3.5 centimeters, and that's being squared, and then we're multiplying that by the height, which is 12.5 centimeters like this. So we just have to work this out. So what we've got here, we've got 1/3, and we're multiplying this by pi. So we've got second and the up arrow, and then we're doing 3.5 squared. So we're multiplying by this, and then finally multiplying all of that by 12.5. So now let's see how this works out. So just analyzing this here, who has more ice cream, we could right away see that Mary is going to have more ice cream. She has 160.35 cubic centimeters versus 100.53. And just remember, justifying our answer just means that we have to show work, and all of this work we just showed here is enough evidence to conclude that Mary has more ice cream. Now for the last part here, we just have to determine and state how much more is served in the larger ice cream than the smaller ice cream, and we're going to round to the nearest cubic centimeter. So all we're doing here is we're going to see how much more ice cream does Mary have than Sally, and to determine that, we're just going to take 160.35 cubic centimeters, and we're going to subtract 100.53 cubic centimeters. And when we subtract these numbers and round to the nearest whole number, this is just going to work out to 60 cubic centimeters. So here's our solution to the second half of the question. So question 33, the triangle proof. Now for these questions, I'd like to take the givens and transfer to the diagram, and then that helps me come up with the strategy. So we have these two triangles. We have segment ABCD, and then we have that segment AE is parallel to segment DF. And we're told next that EB over here is parallel to FC. And then we're also told that segment AC, which I'm highlighting in purple, is congruent to segment DB, which I'm highlighting in pink. So right away, what's jumping out at me is that we have one pair of congruent angles over here. So this angle A is going to be congruent to this angle D because they're alternate interior angles. And then one that's less obvious is that these pair of angles here, angle EBA is going to be congruent to angle DCF. And this is going to be true because these are actually alternate exterior angles. So this might be a little bit tricky to see, but let's say I take this diagram here of these alternate exterior angles, which are outside of the parallel lines, and I turn it sideways like this and expand it a bit. I think here you'll be able to see that this matches what we have going on here, that these lines, if I were to extend EB and extend FC in this direction here forever, it would match what we have going on here like this. So we actually have alternate exterior angles, and that's what we're going to use to write our proof. So now the last bit of information to use here is that we have these two congruent segments, but notice they go a little bit outside the triangles, but they go outside to match this segment BC. Notice that these two line segments, the purple and pink line, overlap at BC. So if we use the subtraction postulate, that's going to tell us that AB is going to be congruent to DC over here. So these two triangles are going to be congruent by the angle side angle postulate. So now that we've got everything mapped out, let's go ahead and write this proof. And the first thing you have to write in all of your proofs are the givens. If you just write the givens, you don't get any credit for that. But if you skip the givens, you're going to lose credit. So now that we got the given set up, let's move on to statement 2. And we're going to say first that angle A is congruent to angle D. And if we look at our diagram, these were the alternate interior angles. And when we have parallel lines being cut by a transversal, the alternate interior angles formed are congruent. So this establishes that we have one pair of congruent angles. So next we can move on to the pair of sides. So now for the next part of this, we're going to establish the pair of sides congruent. And to do this, notice we want to establish that AB is congruent to DC, but they have this extra piece hanging out here at BC. So what we want to do is we want to subtract BC out of the purple segment, and we also want to subtract BC out of the pink segment. So first what we have to say is that BC is congruent to itself, and this is true by the reflexive property. So for the fourth statement, now we could say that segment AB in this triangle is congruent to segment DC in the second triangle. And we're going to use the subtraction postulate now, and we're able to use it at this point because we established in statement 1 that AC is congruent to DB. So that represents the entire segment. And then the piece that we're actually subtracting out in both segments is BC. So once we establish that these two segments here, these two pairs of segments are congruent, now we could say that AB is congruent to DC, because remember, with the subtraction postulate, when congruent segments, that's BC, BC, are subtracted from congruent segments, which we have here in statement 1, the differences, AB and DC, are also congruent. So this establishes that the pair of sides in both triangles are congruent. So now the last congruent statement we have to make before writing our actual proof statement is that the last pair of angles are congruent. And these I could actually label as, let's say, angle 1 and angle 2. And the benefit of doing this is that then you don't have to call this angle EBA and angle, let's say, DCF. So just putting a number there makes it a little bit easier to write your statement out. So I could just say angle 1 is congruent to angle 2 when I label it in the diagram. And remember, this was true because we had parallel lines cut by a transversal forming congruent exterior angles. So now that we've established the last pair of angles are congruent, we're able to finally conclude this proof. So now we could say here that triangle EAB is congruent to triangle FDC, and this is true by the angle side angle postulate. So take a second to read through question 34. So this stuff up here just basically outlines what we have in this diagram. And what we have first here is that Barry claims that triangle ABH is isosceles. And we have to explain why Barry is correct. So they're already telling us that Barry is correct. So what I like to do first is do the math and then think about how I'm going to put that into a sentence. So we have 80 degrees so far on this straight line. So that would tell us the missing angle over here is 100 degrees, because 100 plus 80 would make 180. And then we have this triangle, and so far we have 40 plus 100. So far we have 140. And if we subtract that from 180, that tells us the missing angle at the top is 40 degrees. So right away I could see that this triangle is isosceles because it has two angles that are equal in measure. So now let's think about what we found first, and then we'll put it in words. So we found that this angle here was 100 degrees, and we knew that because these two angles formed a straight line. And if one of the angles is 80, the second angle has to be 180 minus 80, or 100 degrees. Now, once we established that we had a 100-degree angle here, we know that since the sum of the angles of a triangle equals 180 degrees, that the missing angle up here had to be 40, because 180 minus 140 equals 40. So now this establishes that we have an isosceles triangle because we have two 40-degree angles here. So two equal angles means our triangle is isosceles. So for the second part here, we don't have to write any more sentences. We just have to determine and state to the nearest foot the height of the tree. Well, think about what we know so far. If this side here is 85, then this side, because this triangle is isosceles, is also going to be 85 feet. So we established that we have an isosceles triangle. So the sides opposite of the 40-degree angles have to be the same. So now if we focus on this right triangle over here, we want to find the height of the tree. And let's say for now I just call that y. Well, what I could do is I could use our trig functions here. We have SOHCAHTOA. And if we're using this 80-degree angle, the height of the tree represents the side opposite. 85 feet represents the hypotenuse of this triangle. So here I would use the sine function. I would say sine of 80 degrees is equal to the opposite side is y, which is what we're looking for, over the hypotenuse 85. So then here we just call this sine 80 over 1, cross multiply, tells us y equals 85 times sine of 80 degrees. And now to the nearest foot, we're going to have 85 times sine of 80. And to the nearest whole number, that's going to be 84. So our solution here is going to be 84 feet. So we made it to part 4, question 35, the final boss, and this is worth 6 credits. So for this question, I went ahead and copy and pasted the set of axes. And what we have here is triangle DUC with these coordinates. And we want to prove that triangle DUC is a right triangle. So the first thing we should do here is plot these points and connect them. So after connecting all these points here, I think it's obvious that angle U is our right angle. So to prove that we have a right triangle, we have to prove that angle U is a right angle first. So we're going to do that by finding the slope of the segments that build this angle. So let's first find the slope of segment DU. And the slope formula is going to be y2 minus y1 divided by, we have x2 minus x1. So let's say I call this point x1, y1, and I call this point x2, y2. To find the slope of segment DU, I'm doing 8 minus negative 1, and I'm dividing by negative 1 minus negative 3. So we work this out here. This is going to be 9 over positive 2 after we have negative 1 plus 3. And now, next I want to find the slope of segment CU. So we're finding the slope of segment CU, and for this one, we're doing these 2 points. I'm going to have 6 minus 8 over, and I have 8 minus negative 1. And notice here 6 minus 8 is negative 2, and on bottom we're getting 8 plus 1, which is going to give us 9. And these slopes here are opposite reciprocals, which tells us that these line segments are perpendicular. And now that we've established that these two lines are perpendicular, we could say that angle U is a right angle, and therefore triangle DUC is a right triangle. Now for the rest of this question here, we have point U is reflected over DC to locate its image U prime, forming quadrilateral DUC U prime, and we have to prove that this quadrilateral is a square. So the first order of business, if this is going to form a square, I'm going to use the fact that all the sides are going to be equal in measure. And I think about how do I get from point U to point C like this, or to get from point U to point D. And notice I have to go up 1, 2, 3, 4, 5, 6, 7, 8, 9, and I'm going over 2. So what I'm imagining in my head for this question is that I'm going up 9, and then I'm going over 2. And now watch what happens when I go from U to C. I'm going down 2 over 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'm going down 2 over 9. And then if I want to get from C to U prime, I'm going to go down 9 and to the left 2. So I'm going to go down 1, 2, 3, 4, 5, 6, 7, 8, 9, and I'm going over 2. And this is going to bring us to U prime. So if I actually count this out here, this is going to be over 6 and down 3. So this is going to be at the point 6, negative 3. So now if I connect the rest of this here, notice what we have is that we're going to have a square like this. So this is definitely looking good so far. So to prove that this quadrilateral is a square, what I think is the easiest way to do this is just to find the length of all four sides. And we already proved in the first part of this question that this angle over here, angle U, is a right angle. So if we have 4 congruent sides in a right angle, that would prove that this quadrilateral is a square. So then we could start this off by finding the length of DU, and we're going to use the distance formula here. Now be mindful, I said we have to go up 9 over 2, so I already know that I'm going to be doing 9 squared plus 2 squared underneath this, but that's just going to kind of guide me in case I forget the distance formula. But let's go ahead and we're going to do the difference of the x values. So here I could say negative 3 minus negative 1, and this is being squared, plus I have negative 1 minus 8, and this is being squared. And this, if we just simplify this in a calculator, or we could just kind of do this in our head here, this is going to work out to 2 squared plus 9 squared. So I have what I have under here is actually going to be negative 2 squared, which is 4, plus negative 9 squared is 81, and 81 plus 4 is going to give us 85. So we have square root of 85 under this radical. And now if I repeat this, let's say I use this for the length of CU. For CU here, we're going to have the square root of, and we know that this is going to be a square, so we should be getting square root of 85 again. And what we have here is, let's say I do the difference of the x values. I have 8 minus negative 1, and this is being squared, plus, and then we have 6 minus 8 being squared. And if we work this out, we don't have to show all the gritty steps of simplification here, but we have 9 squared plus negative 2 squared, which is also going to give us square root 85. So we'll just do this 2 more times to find the length of CU prime. Now we're going to find the square root of, we have the difference of the x values. So we have 8 minus 6, and this is being squared, plus we have 6 minus negative 3. And this is also being squared. We'll extend our square root, and this is going to work out to the square root of 85. So now we just have to do this 1 more time. So we're going to find the length of, let's say, du prime. That's the 4th side of this square. And this is going to work out to, I would do 6 minus negative 3. So we have 6 minus negative 3, which is being squared, plus, and then we have negative 3 minus negative 1. So negative 3 minus negative 1, and this is being squared. And this is going to work out to square root 85. So now let's combine everything. Since all 4 sides of this quadrilateral are equal in measure and we have a right angle, that tells us that DUC U prime is a square.